So today, let's try to do this LeetCode question, which is number 91. So my habit to do the question is first try to do the analysis for the question. So let's read through the question. So a message contains letters from A to Z can be encoded into a number. So basically, there's kind of like one-on-one correspondency. So to decode an encoded message, all the digits must be grouped and mapped back to the letters using the mapping above. Yep. So for example, 11106 can be mapped into. So there are different ways to disassemble the string and map it back to letter string. So, but some of the cases are invalid. For example, 06, since we can starting from 0, so we can pick this kind of disassemblization and return the number of ways to decode it. So that's our task for this problem. So let's do a quick analysis on one of the string. So for example, as the question given, we're trying to do the 11106. Okay. So the way I was trying to solve this problem is through dynamic programming, and especially the iterative version of this. So I will teach you guys a framework that I learned from my college class. I think it's pretty useful for you guys to think about it. So let's find the first task we need to do. So the first thing is we want to um, find what is the subproblem is. Okay, let's see. So what is the subproblem? It's usually like a subtask you can handle. So like you can get the trying to solve the larger problem based on those like subproblem. So in this case, we can see like if we just think about the thing in the first index, the only way we can encode this single string is just one, because it itself is as a string. Uh, yeah, but think about this. What if it's like 01106? In this case, this will instead be 0 because we can starting with 0. This is kind of invalid for this question. Okay, so back to this problem. So if we do have a DP, right here, so in the first index in this case, in this example case, it's gonna be 1, and for the second case, what's it gonna be? Like based on our mind, we'll say it's probably gonna be 2, because the which is the 1 1, you can split it into 2a, and also 11, which corresponding a letter as well. Okay, now comes to kind of like interesting part. What will happen like at the third position? Okay, so let's try to finish this subproblem first. So we know the subproblem is the number of way to decode the string for the more accurate is the substring from 0 to I. Let's say I is the index, random index that we pick. Like, so for this case, you want to know what is in dp when I is equal to 2, right? So here's our, so let's just change it back to string to make it more generalized. Okay, so this is our subproblem, and the second thing we need to know is what's our goal is. So our goal is actually to return the dp 0, 1, 2, 3, 4, dp4 in this case. Why? Because in that case we consider the whole string, and we want to know like what's the total possible number of way to to do the decoding stuff. So like if let's just say the length of the string is n. So our goal is actually to find a dp of n-1, right? Because it's 0 indexing. But we will change this in a little bit. Let's see why, the reason why. Okay, the third is back to our question. We want to find what's the recursive relationship. This is kind of like the hardest part for all the dynamic programming problem. So when it comes to back to these examples, when we see I is right here, how can we know what to put in the DP? based on the result previously, right? So we should think about this. At position I, what's the possible way, to utilize this bit? The first possible way, like, is just treat itself as an individual bit, and like how many ways you can get this string, and you just concatenate this string after that. So it itself is like a valid decoding way, which is all equal to this one, because you just concatenate one character to how many ways you can create this string, right? So let's try to do this. So the dp of I, it probably you want to depart like I minus 1, right? You probably need this part, as we said, like you just take this bit as a single string. Okay, so is there any other way you can interpret it, this thing? Right, I think you probably were thinking about is like, what about we take 2 bits of them? Like, so in this case it's 1, 11. So if this is a valid 2-digit number, we have to make sure it's between 1 and 26. If this is valid, so this is also a way to disassemble it, is 1, 11. So how this is related back to our DP array. So we know that this 2 part is how many way I can make up this part and concatenate this valid string, right? So it's really based on how many ways we can make this string like 2 slot before. So this helps us to conclude that what is dp I minus 2. So this is kind of like the recursive relationship, but could we just put this in our algorithm? The answer is no, because remember, there are some of the cases like there was there. In that case, we have to thinking about is the thing still can be added, right? So let's just put it in the different line, and okay, let's do the analysis on this. So when can we add in this part? So let's think about this. If I is at this index, okay, if this case, you can consider this digit as a single number, because it's 0. There's no correspondence character in that way. So in this case, you can do that. So if char at I is equal to 0, so we do this when it's not equal to 0 actually, right? Okay, now let's think about when should we consider this case, right? For this case, as we said, like during our explanation process, we have to make sure that this is a valid integer, right? So only if the number that created by the sorry, it's just the pseudocode. So the number created by the I minus 1 and I is within 1 to 26 boundary included. Okay, looks good. Here's the other way, like here's the other cases that you should also think about when it comes to dp I minus 2. So think about this, right? If we say our I is in such a position, right? Okay, we will evaluate this 2-digit. Okay, it's 6, which is kind of like a valid number, right? Which is within this range. However, which is also been mentioned in the question, like we can have initiate 0. So we also, so other than that, we also, honestly, we should actually even check before this. We first check if char at I is 0, right? If it's not, we can do this part of the check. If it is, we can just omit this part because this is not a valid way to think about this, right? Okay, so now we have set up our recursive relationship. So the last thing is like, what's the direction you want to go through this list? You probably can think about since our DPI is based on the result before, so it's kind of like from left to right, because we're thinking about array like 1, 0, 1, 2, 3, 4. Like we want to fill it out in this direction, right? Okay, now we have setting up the whole things. So the last thing we need to think about is like there's an out of bound problem. Like if we're trying to fill out this array, right? So say let's when I is in 1, if we want to go 2 back forward, it's actually out of bound. So how can we solve this problem? So the correct way to think about this, like, what if the string is empty? How many ways could we encode it that? We can just put a 1 there, right? Because there's only one way you can encode it, an empty string. It's like, basically you can do nothing. So subtly it's 1. Hopefully that makes sense, and I think it will be more clear when we go through the code implementation. Okay, so that's all for the explanation part for this question. Let's dive into the coding part. So probably we have go through all the thoughts in our planning phase, so it will be fairly easy to transfer those language into our Java. So the first thing I prefer to do is always put some constant, right? If we get the length, we're here. And now we should think about some of the base cases, or more precisely, as edge cases. Okay, so let's think about this. As we mentioned that if the first char of the string is 0, so if our char at 0 is actually equal to 0, we will return 0 as well, right? Because there's no way you can decode that string. So this is one of the edge cases. So what else? The other thing is like if we only have a single character in that thing. In that case, we can just return 1. That's the only way we can encode it, right? And we also know that the single digit were for sure within this bound. And some people say, what if that single string is 0, right? And this has been handled in this edge cases. Okay, nice. And then we have to set up our DP array, right? So DP is equal to new in. So for the size of it, it's actually len plus 1. As we talk about, we have to put, also thinking about like if the string is 0, of course we know that it's not possible as an input, but we think about this to help us handle the out of bound problem. So, okay, and also let's see our planning. So as we said, we put the first one as 1. We also, when there's only one string there, the output should also be 1. Okay, now after we put in the base cases, okay, let's say these are base cases. After we finish the base cases, we have to do the recursive part. Okay, so as we said, the direction is from left to right. So let's set up a for loop. So int I is equal to, so things 0 and 1 has been filled. We started from 2, which is like starting from the second character of the string. But when we're trying to do access the character though, since the string, like the char at is 0 indexing, so we need to make one adjustment left. So be careful about that. So when it's smaller than len plus 1 and I plus plus. Okay, we set up the for loop for us. And let's just do the check based on our explanations. Let's see what we gonna put inside the for loop. So as we talk about here, like there are 2 possible things we need to thinking about. So the first step is we check whether the character at the current position is equal to 0. If it's not, we can plus this part of the like I minus 1 part, and then we do this a bunch of check. And if this is qualified, we will add up this part as well. Okay, so let's do everything this. So let's first do whether the current chart is 0. Okay, so let's say if s dot chart at. Remember, this is I minus 1 actually, because as we said, our array is starting from empty string instead. So we have to do this adjustment. So if it's equal to 0, let's just say if it's not equal to 0, right? That's the case we want to do the addition. So we say dpi is plus equal to dp I minus 1. Okay, looks good. And then let's trying to fetch out that number, which is we talk about here. Let's fetch out what's the value for this two part. Okay, so we can use a thing called parse n and substring. So let's try to do it. So it's num. We start in an integer, and there's a search function in Java, and we pass in the n, which is like the substring. So it's s dot substring. Let's think about the indexing. So the current position is at I. So actually I minus 2 is the starting position, right? Because we have to like say this is the chart position you are at, but for the character is actually at starting at this thing because you want to go one forward and one forward again, which is the adjustment, right? And you were stopped at the I. Okay, now you get the numerical value for those 2 bits, and then you have to do the checkment that we're thinking about, right? So first thing we have to make sure that it's not a 0 char. So we say s dot char at, and don't forget we need to make the adjustment. It's not actually, it's I minus 2. It's not equal to 0 char, and we have to make sure that this num is within the bound, right? So where we go to 0 and num is smaller than 27. If this is still the case, add I minus 2 plus equal to dp I minus 2 to our dpi. So after we go figure out everything in the array, we can just return dp dot land. Okay, hopefully this makes sense, and we try to run in the code. It do pass our task cases, and it looks pretty efficient. And thank you so much. As you can see, I tried a shit tons of this before I getting this, so just be patient. Give you some times. Okay, bye bye.